In this lab, we'll configure eBGP between company A, which is in autonomous system 444, and transit A and transit B. We'll also have eBGP sessions between company B and transit A and transit B. Inside company B, we'll run OSPF, which will be used to share loopback addresses between the OSPF routers, and this will help us to create eBGP sessions using loopback interfaces. We don't have access to transit A and transit B, and all the work will be carried from company A and company B. Also, this lab will be conducted in two parts. In the first part, we'll finish the BGP configuration in all of the topology, and we'll share routes. We'll share PC3 and PC4 routes to company B, and after that we'll share PC2 and PC1 routes to company A. In the second part of this lab, we'll implement some traffic engineering, and I will give you more details when we'll start the second part. So for now, let's start with configuring the BGP. So the first thing to do when configuring BGP is to set routing options autonomous system. If you don't have an autonomous system configured, Junos will not allow you to commit the configuration. So this is a must-have knob. In our case, for the VMX1 autonomous system is 444. Let's commit. So after that, we can go ahead and configure the BGP sessions with 3 of our peers, 2 from transit A and 1 from transit B. So set protocols BGP group. We'll call the first group transit A, and we'll specify that this is an external BGP. So we'll have 2 members or 2 neighbors. It's 12.12.12.2 and 13.13.13.3. And we also should specify the peer IS, which is 111. Also, let's create a separated group for transit B. Set protocols BGP group transit B peer IS 222 and neighbor 18.18.18.8. You can go ahead and commit this configuration, and let's check the status of our BGP connections. For that purpose, we can use run show BGP summary. And as you can see, the BGP is in active mode right now, and virtual MX2 just switched to established, and now all of the members are in established mode. Okay, that's cool. Also in this output, we can see the active, received, accepted, and dumped routes. Now we are not sending any routes. And we have a colleague which works in the transit B, and we can ask him if he receives any routes from company A. So show route, and we don't see any routes received. But also, if we are more knowledgeable in BGP, we can issue run show route advertising protocol BGP, and if we enter the neighbor number, we can see which routes we are advertising to one of our neighbors. In this case, we are not advertising any route to any member. We can check that for 13, no route, and we can also check that for 18, no route. Okay, the company A configuration is almost done, we will go to company B, and as a prerequisite, you should have configured the OSPF. And as you can see, OSPF is configured, and we can check if we can see our neighbors. The best way to do that is go to VMX6, because it will have all the connections, and run show OSPF neighbors. You can see that all the neighbors are present, and we also can do run show route. And we can see if we are receiving the all loopback addresses. We are receiving 40, we are receiving 50, we are receiving 60, and we are receiving 70 loopback addresses. Also, I didn't mention that our loopback addresses are configured like that: 60.60.60.60 on VMX6, 40.40.40.40 on VMX4, and so on. Now you can configure BGP or iBGP in two ways. You can use physical interfaces, or you can use loopback interfaces. It is advised that you use loopback interfaces because if you use loopback interfaces, you can establish BGP through this member, for example, even if the connection is down. I will show you how this works with BGP peering from VMX4 and VMX7. So what I'll do is set protocols. BGP will have our internal group, which is company B, and the type of this BGP will be internal. We will configure the neighbors, which would be 50.50.50.50.50. The 60s now, 60.60.60.60, and the 70s, 70.70.70. And what else we need to specify is the local address, which is 40.40.40.40. I will go ahead and actually let me check if I have the autonomous system configured, and I don't. But if I don't have it configured and if I try to commit, I will get this error. You must define the local autonomous system. So to do that, set routing options, autonomous system, which will be 333. And now I can commit my configuration. Moving on VMX5, set protocols BGP group company B, type internal, neighbor will have 40s, will have 60s, and we'll have 70s. And we have our local address, which is 50s. Let me check if I added all the members here, and I did. Now we can move to virtualmx 6 and set protocols BGP group company B, type internal, neighbor will be 40s, 50s, and 70s. And the local address, which would be 60s. And I will commit that. And we'll move to VMX7. Again, set protocols BGP, the same group. Also, the group name is not so important. It has a local significance. Company B, type internal. We'll go with local address, which will be all 70s, and neighbor We'll start with 40s. We'll move to 50s. And we'll move to 60s. And I can commit that. And I forgot the autonomous system. Set system routing options. Routing options. Autonomous system, which is 333. Actually, I will copy this. Now I can commit. Paste it here. Commit. Paste it here. Commit. Now I will move to VirtualMX 6 and let's see the BGP. Run show BGP summary. So BGP will go up slowly, and now every BGP neighbor is up. What we can do is to go to VMX4 and configure the rest of the eBGP peers. So it would be set protocols BGP group transit A, type external, and we'll go with neighbor, which would be 24.24.24.2. For eBGP, I'm using the physical interfaces, but you can use also the loopback interfaces as well, but nobody is doing that. Actually, it should be 34.34.34.3, and the PRIS should be 111. I'll go ahead and commit. And let's check the BGP status. Run show BGP summary. Have 2 new connections, which should go up any minute. Any second, actually. Unless something is wrong. And VirtualMX 2 is up online, and VirtualMX 3 is also online. Note that we are not receiving any routes yet from any of the BGP peers. Now let's move to VirtualMX 5 and set protocols BGP. We have one connection in transit A and one connection in transit B. So we'll have to configure transit A first with type external peer AS111 and neighbor should be 35.35.35.3. And actually I will configure also the transit B. So transit B type external peer AS222 and the neighbor is 85.85.85.8 and I'll commit that. If I check the BGP summary, I can see that the connections need to go up and they are in active mode. One transition to established and the second also transition to established. So good news. The BGP is up and running in our whole topology. But if we are checking the routes, let's check the far right router. We are not receiving any BGP routes at all. So one important thing to know about BGP is that it will not import non-BGP routes by default. So you'll have to teach him which routes to import or not. BGP will only import routes which are learned from other BGP peers. So for example, if we want to leak OSPF routes into BGP, we'll need to have a policy. If you have to leak the specific addresses in the BGP, we'll have to have a policy. On VirtualMX1, I will do the following. I'll create actually let me start from VirtualMX7. No, I will start from left to right. So on virtual MX1, I'll set policy options, policy statement. I will have the policy will be called import, so or PC3 to BGP. So from route filter, we'll create a policy which will import the PC3 route. So we'll import the PC3 subnet. So from route filter 3330/24 exact, this will import the exact this exact route as long as it is present in the routing table. And after that, I will add then community add, and I will create a community. This community will be called company A, and after that I will add another statement which will say that then accept. Now I will have to create the community company A. So set policy options, policy statement, policy options, community. My community will be called company A, and I will add it. The members would be 444.101, and I will add it. Now also let's create a policy which will import also PC4 here. We can do it in two ways. We either add another line in this policy here, or we create another policy from scratch. I don't want to create another policy from scratch. So what I will do, I will use this policy, and I will add also PC4's subnet, and I will apply this policy under transit A one time as a export policy, and I will add this policy. Actually, now that we decided that we'll do that, maybe I should change the policy name so we have everything here nice and clean. So I can go with rename to policy statement PC to BGP. Let me check. And the new policy is called PC to BGP. That's perfect. We can add it under transit A group as an export policy, and we can add also under transit B. If I'll go ahead and commit it, and if I go to virtual MX7 and I will check the routes, run show route, I still don't see any BGP route here. But what about virtual MX6 run show route? Still no trace of a route. But about virtual MX5, here we have two routes for each of the PCs, which are learned from two different sources. And on virtual MX4 run show route, we also have the same situation. Two routes learned from two different sources. But why don't we have this route also present on virtual MX6 and 7? Well, that is because if you remember our lecture, we should have a next hop self policy as an export policy, so that routes received from eBGP, when they arrive at the eBGP peer, they would insert their next hop, and they can be transmitted to other peers. In our case is virtualmx6 and virtualmx7. So virtualmx6 and virtualmx7 will install those routes because they will have a reachable next hop. Okay, so to do that, I will do set protocols, actually set policy options, policy statement. I will call it the next hop self, and then next hop self. It's pretty easy to configure, just one line. I will copy it, and I will add this policy to virtualmx5 because we are in the same situation. So let me check my BGP configuration, and for transit for company B, I will add it as a export policy. Okay, and for virtualmx5, I will add also it as a next hop. It is an export policy. And now if I go to virtualmx6, I can see that the routes are learned. And to virtualmx7, I can also see the routes in the routing table. But as you can see, this is not your usual BGP setup. As you can see, we don't have a physical full mesh of BGP connections, but we rather have a logical full mesh of BGP connections. So we used OSPF to learn all the loopback addresses from our devices in company B. So when we created BGP, we will have sessions with each of the BGP members. So it's a logical full mesh configuration here. And as you can see, we are receiving routes from peer 40 from VMX4 and from VMX5. And the best route was chosen as the routes received from VMX4. Okay, and if you check the routes on, let's check on VMX7, run show route. Let's check, for example, this route and add extensive. If we check this route, we will see that it will have this community that we configured on VMX1. And our customer, which requested us to configure this topology, he said to explicitly accept only the routes with the community that we configured here. So we'll do that. We'll go to VMX4, add the community here. We'll go to VMX5 and add the community here. And we'll create a policy to accept only this community. So set policy options, policy statement. We'll call it accept company A, and from community we'll add community company A, and then accept. And if we go to our BGP configuration for our external BGP peers, we'll add here an import policy for the which will accept company A. And also if we go here, show protocols, display set, we will have to add this this policy as import policy. Actually, I need to copy it from here. So I will copy this line, and after that this line. I already have copied the community, so that's fine. And if I go to transit A configuration, I would teach it that it should import only routes with community company A, aka 34101, and the same for transit B. Let's commit here and let's commit here. And let's check if it didn't break anything. So we didn't break anything. The routes are received with the correct community. For example, let's check something here. Display set. Let's deactivate this knob here. Say deactivate, company A, commit, confirmed 1. If you'll go to VMX7 and run show route, show policy options, display set. So we'll have to modify this policy, and we'll go ahead and remove it because we should also have a deny statement. So we'll do that. Community A, we'll add term 1 from community company A, then accept, and term 2, then reject. So let me commit this and let's check what is happening here. And as you can see, now we are receiving these BGP routes only from one BGP neighbor. So what we do, we need to go to virtualemx4 and set and check the policy options. We also delete this policy and we'll copy it from here. Show policy options, display set. So we'll copy the modified policy here. Accept company A, term 1, then accept, and term 2, then reject. And I will commit it, and let's check the route situation here. Let's check the show policy options, display set, and show policy options, display set. Oh, okay, I think see what happened. So I'll do rollback 1, show compare, and it will deactivate this policy, and I will commit confirmed for 1 minute. And now I am not tagging the route with a community. If I go to virtualemx7 and if I'll check the route, I can see that I am not receiving any route. Also virtualemx6, also no route. Run show route here, no route. Run show routes. So I will receive only the routes which have a community tag on them. So let's roll back here and enable the communities again. And let's check the routes here. Now we are receiving both of the routes. Let's share the PC1 and the PC2 routes to company A. So to share the PC1 route, we'll go here and we'll create a policy. Set policy options, policy statement, PC1 to BGP. We'll do from route filter 1.1.1.0/24 exact. Actually, we have some different options here for the route filter. We can do with exact. We can go with longer than /24. We can go with or longer, which will mean it will include /24 and longer addresses. We can go with a prefix length range, and we'll go through and up to. And you'll have the descriptions for each of these knobs, and you also have a lot of descriptions for these knobs in Juniper Online documentation. So from route filter, exact, we'll do the same thing here, then community, add. We'll go with company, be community, which will be 333.2.101. And then accept. Let's create the community, set policy options, community, company B, and the community will be members 333.101. Let's apply this under the BGP as an export policy, and neighbor, not neighbor, export PC1 to BGP. Let's commit and check this side here. Run show route. And we are also receiving this this route on the company B side. And let's do the same thing with PC2. So set policy options. We'll add the community first. The community is company B, and the members are 333.101. We'll add the policy, set policy options, policy statement. PC2 to BGP from route filter 2.2.2.0/24 exact, then statement, then community, add company B, and after that we'll accept it. Show protocols, display set, we'll add it under the company B configuration as a export policy. PC2 to BGP, let's commit, and let's jump here to check our route, and voila, we are receiving the two routes from company B. But let's do some filtering here for the community. So again, set community. We'll have to add set policy options. Community, company B will have to have the community configured. Members 333.101, and set policy options, policy statement, accept company B from community company B, then accept. Let's go to show protocols and see the BGP configuration, and again we'll apply it under transit A as an import policy, accept company B, and under transit B again as an import policy I'll hit commit, and let's check the routes. All good. It means that the community matches, and our configuration looks really nice. On show route, run show route 2.2.2.2 detail, and we have the community tag, and it was checked and accepted. So this was the first part of our lab. We are sharing the routes from site to another. And in the next lab, I will show you some really cool things on how you do some traffic engineering working with the BGP attributes that I have presented to you in the lecture. See ya, bye. So on a quick side note, like I said, you can find the video series links in the description, and you can watch these videos chronologically. You can also hire me on Fiverr. I offer consulting and design services, troubleshooting and whatnot. And if you want to follow along with my Udemy courses, you will also find the discount codes in the description. Thank you, and I'll see you in the next one.